All right, everyone. So this is notes 4. It's probably going to be 2 parts. So we're going to talk about complex numbers. So you get that when you apply your radical properties and you can end up with complex numbers. So a complex number is really set up where you have something like this. You have this expression. So A plus B times I, where A and B are real numbers and I comes from the I squared of equaling -1. So we've touched on this a little bit. So I is equal to the radical -1. I squared is equal to -1 because it gets rid of that radical. I cubed, which is really I squared times I, is equal to the negative root of -1. And then I to the 4th is just a +1. And it's a cycle like that. It's a cycle like that. So, and if you remember, I to the 4th is I squared times I squared. So something squared times something squared. This is -1 times -1, which is why you get the positive. So it's cyclical like that. So we'll talk about how to solve problems where you have to do that. But it's typically when you have complex numbers, you're writing it in some sort of expression like the A plus B times I. So adding, subtracting, and multiplying with complex numbers, it's the same as when you have a variable, X or Y. You're going to look at for your like terms. So I'm highlighting my like terms while we're talking, and you're just going to combine them. So when you have adding, it makes it really easy because you can just say, well, 3 plus 4 goes together, 5i minus 2i, they go together. So I have 7 plus 3i, and it should be in the form that we just talked about of the a plus b times I. So it is, so we are done. That is our solution, 7 plus 3i. When you have subtraction, the subtraction has to get distributed. So you have 3 plus 5i minus 4 plus 2i. You're going to treat I like a variable until you have to do something with it. So we have those like terms, 5i and 2i, and then we have 3 and -4. So I really have -1 plus 7i here, and it's written in the right form, so we're good. So we're done with those two. Okay, so adding and subtracting is pretty straightforward. It's just combining like terms, and that's really what you need to focus on, is just the combining of your like terms. Okay, so when we get down to part C and D, part C, you're multiplying. Okay, you can see I have two binomials sitting next to each other. You're still going to FOIL how you normally would. So 3 times 4, I have 12. I have 5i times -2i, so I have a minus 10. 5 times 2 is 10. And then I have 2i, so I'm going to just write that I squared next to it. And I'll do something with it in a minute. Then I have 5i times 4, which is 20i. And then I have 3 times -2i, which is -6i. I do it like this because for complex numbers, it's really easy to see the form, and you don't have to move stuff around. So now at this point, if you start gathering I squareds or thirds or fourths, whatever it is, we need to do something with it. So I squared, remember, is -1. So really you have 12 times -10, or 12 minus 10, multiplying -1, and I'm just going to go ahead and combine my i's over here. So I should have a 14i in the back. Okay. So now because this I squared changed to a -1, it changes this term's sign. So this becomes a plus because they multiply together. So now we have 22 plus 14i. Okay, so that's really the only difference so far. It's not too bad. Okay, so now let's take a look at part D. So part D, you have I to the 23rd, and it wants you to simplify. So you're not going to write out square root of -1 times square root of -1. You're not going to do that 23 times. What I recommend you doing, oh, I don't know why that got so big. What I recommend you doing is split it. If it's an odd number, you're going to split it into the evenmost number you have times I to the first. Okay. because I squared is -1, okay? And so I to the 22nd is really, if I'm working backwards through my exponent properties, is really I squared to the 11th, or you can say I to the 11th squared, however you want to do it. I prefer this one because I think it's easier to see. So this is saying you have I squared 11 times, okay? So when you're multiplying -1 11 times, because that's really what we have, you end up with a -1, okay? So now I to the first, we're not going to rewrite it. We're not going to write it as the root of -1 because that's not simplified. They created this imaginary number with this letter for a reason. What you need to simplify is this evenmost power of I, of that imaginary number. And by doing it this way, you can pick out whether you're going to have a positive one or a negative one. And so this -1 now is going to multiply with your remaining letter I, which gives you a negative I for your final answer. Okay, so that's how you would do that. That's how I recommend you doing it. You're going to work backwards using your exponent properties. So what I want you to do now is I want you to do letter E on your own and then check your work. Okay, so go ahead and do that now. So for part E, we actually get really lucky because we have a -12i and a +12i. So even though these aren't factor difference of squares, we do get those to cancel. And then your -24 here turns to a positive because of the I squared, if you remember. So your answer is actually just 30. Okay, so make sure you check your work. If you have questions about that, ask. But I am going to have you do part F on your own. I know you can FOIL, I know you can collect like terms, and now we're practicing that with I, so go ahead and do that now. All right, so when you FOIL out the first two binomials, you end up with 1 minus 12i squared plus 4i minus 3i. So when you simplify that, you actually end up with 13 plus I. I would simplify as you go. So when you combine these two, you end up with just 1i. This 12, because it's multiplying by I squared, which is a -1, changes to a positive, and that's 1 plus 12, so you get 13, and then you FOIL again, and you should end up with an 11 plus 27i. Okay, so if you have questions about that, just let me know. So I want to move into dividing complex numbers. So dividing complex numbers, we're going to use something called the conjugate. Okay, to get rid of an I in the bottom, which can't happen, you're going to use the conjugate. So you can't have I in denominator. Okay, so the example I want to use is 2 plus I over 3 minus I. And so we have this I in the bottom, and that can't happen. So the conjugate, when we multiply the top and the bottom by the conjugate of the bottom, that's what we're looking at, of the bottom, is just the same thing, except for we have a plus sign between the terms. And the reason for that is really now in the bottom you have 3 minus I times, if my pen will work, oh my goodness, 3 minus I plus, times 3 plus I, and then when you FOIL it out, like we're about to do, our I's will cancel, because this is essentially creating difference of squares, so your dots. This is what dots factors out to be, so we want to create that so it'll cancel the I. So my top is 2 plus I times 3 plus I, and then the bottom, because we're going to FOIL, we have 9 minus 3i plus 3i minus I squared. Okay, so if you FOIL at the bottom, that's what that looks like. So now when we go to simplify, we simplify the top, but you can see in the bottom, this middle term cancels, which is what we want. But then this I squared, remember, is -1. So this really changes to 9 plus 1, which equals 10. So whatever our top simplifies to be, we now have just a number in the bottom, which as long as there's not an I there, we did something right. Okay. So for that example, all we really need to be sure about is that the bottom doesn't have I in it. So I want to show you, we can go ahead and simplify the top, I guess. So we have 6 plus 3I plus 2I plus I squared. So we really have 5 plus 5I, and you could simplify that further. We're not going to. I want to get moving. I want to talk about what a conjugate looks like for these scenarios. So you have an example of each. So if we have 3 plus 2I and we need the conjugate, like I just said, it's the opposite. So we're going to have 3 minus 2I. If I have something like 1 minus I, like we just did in our problem, then I'm going to have a plus as my conjugate, 1 plus I. If I have 4I in the bottom, then my conjugate is going to be the -4I. And then if I just have a 5, it's a constant, the conjugate is just 5. It's just, you don't really need to simplify the bottom. So it's there if you need it, but that's what it is. So we're going to do a couple examples. Okay, so we're going to do a couple examples. So example 2, express the following in the form a plus bi. So we have 3 plus 5i all over 1 minus 2i. So we need to use the conjugate to get rid of the I in the bottom. And the conjugate is just the plus that we talked about, the opposite of what the middle sign is. So I'm going to multiply the top by 1 plus 2i, so 3 plus 5i times 1 plus 2i, and then the bottom 1 minus 2i and 1 plus 2i. Okay, so we need to FOIL the top, we need to FOIL the bottom. So when we do that, we'll do this just the whole example together. So when we do that, the top, we get 3 plus 5i plus 6i plus 10i squared. Sorry, I went out of order. It caught me off guard. So that's our top. Okay, and we'll combine our like terms. The bottom, same thing. So we have 1, we have minus 4i squared, we have a minus 2i, and we have a positive 2i. So the top, I have these two that can be combined, the 5i and the 6i. And then I also have this I squared to deal with. Okay, same with the bottom. I have the I squared, and then I have my like terms. So for the top, my 5i and 6i, that's 11i. And then I have an I squared that changes to -1, which means that this 10 is negative. So really I have a -7. 3 minus 10 is -7. And then the bottom, the two i's cancel. This I squared is -1, so it becomes a +4. So this is over 5. So we did our jobs, we are done, and that is that. Okay, so that's how you use your conjugate. So I want to take a look at B. We just talked about B a little bit with the example. So for B, we have 7 plus 3i all over 4i. And we literally did the example of our conjugate, and that was the opposite of 4, which is -4, and then the I with it. So the top and the bottom gets multiplied by -4i. So we are going to end up distributing this into our top, and then the bottom is -4 times 4, which is -16, and then you have an I squared. So we need to simplify and do the rest of the work. So -28i minus 12i all over, and then I'm just going to go ahead and simplify that I have this -1, which makes the bottom 16. So now, this should be an I squared. Okay, I squared, sorry. We have an I squared up top. So this should be a -1, which changes the 12 to a positive. So the top is 12 minus 28i all over 16. We can simplify further, and we're going to. So 12, 28, and 16, they all have a GCF of 4. So we're going to divide out of 4. So 12 divided by 4 is 3. 28 divided by 4 is 7. And 16 divided by 4 is 4. Okay, so you can see it's very similar to what we started with, but there's no I in the bottom, which is what we want. Okay, so what I want you to do right now, I want you to do part C and part D on your own. So go ahead and do that now. All right, so here's what I have for part C and part D. So for part C, the conjugate is 1 minus I. And then you're going to FOIL, combine your like terms. So I ended up with -7 minus 11i all over 2. So for part D, the conjugate is -2i, so top and bottom. Distribute it in the top, so you get -18i minus 30i squared, and the bottom is -4i squared. The I squareds are -1, so the 30 is now positive, the 4 is now positive. 30 minus 18i all over 4. They have a GCF of 2, so 15 minus 9i all over 2. So those are the two answers you should get. I think I'm going to stop the video right there because it's getting a little long. We'll do a part 2. We'll start part 2 with our square roots. Okay, so have a good day.